Hello and welcome. My name is Alisa and I'll be your guide today as we explore the what and whys of GPU resource sharing and how Compute Grid aims to demystify this process for users of all skill levels. Whether you're a seasoned developer or new to the world of high-performance computing, we're here to ensure that accessing GPU resources is as straightforward and hassle-free as possible. First, what is a GPU? GPU stands for Graphics Processing Unit. It is a specialized electronic circuit designed to alter memory to speed up the process of creating images, videos, or animations. GPUs are also optimized for parallel processing, making them exceptionally good at handling multiple complex calculations at once. This ability makes them ideal for graphics rendering, video processing, and running complex algorithms. In essence, the GPU takes over the most computationally demanding tasks from the CPU, allowing for smoother, faster processing and rendering. So that brings us to our next question. What then is a GPU marketplace? It is essentially a hub where individuals can either offer their unused GPUs for rent or access GPUs provided by others on a pay-as-you-go basis. This is mutually beneficial as the owners of GPUs, who may not always utilize them to their full capacity, can rent out their excess computing power. Then, users who need additional GPU resources for tasks but either don't have the physical hardware or prefer not to purchase expensive GPUs can rent out these resources. This effectively saves guest users money and allows GPU hosts the opportunity to gain passive income. Now that we understand the basics, let's move on to exploring this platform. We'll start by clicking the Sign Up button. This allows us to log in with an existing Google account or any other email address you may have. From here, let's navigate to the Profile page. Here we can easily modify our personal information, enable notifications, and set a public SSH key. This is an optional feature Compute Grid added so users wouldn't need to repeatedly enter a new instance password. On our left-hand side is our navigation links. The dashboard displays quick information at a glance, such as available GPUs. We can see a better view of the machines and their GPUs in the All Machines tab. Here we can see the host's given machine name, the GPU type and amount, the CPU cores, RAM and disk space, along with a reliability score. If we click on a machine, we enter the machine detail page. Here we may see some familiar information along with something new, like scores. Each score represents a different but important value. The uptime score is calculated by looking at the amount of time which a machine is operated within the given month. The reachability score is calculated based on the number of heartbeats missed by the machine. A heartbeat is a signal that is sent periodically to check the status of said machine. The total reliability score then takes both values into account. Below our scores and machine information, we can see this machine, there are two available instances. How are two people able to rent the same singular machine? It's really rather simple. Think of the machine as a large office building with many rooms. Each room can be rented out to different individuals for various purposes at the same time. Even though everyone shares the same building structure, each tenant has their own space to work independently of the others. We can rent an instance directly from the machine detail page, or if we wanted to view all the available instances without grouping it by machine, we'll click the All Instances tab here. From here, we can see much of the same information as before, but let's quickly break down what they all mean and what their relation to each other is. We already know about the GPUs. It is the powerhouse for processing graphics and visual content. The VRAM is special memory used by the GPU. Think of it as a dedicated disk space where the GPU keeps all of its current project materials for quick reference. More VRAM means more space for these materials, which can improve performance, especially in graphics-intense tasks. Now on to the CPU cores. CPU stands for Central Processing Unit, and is like the project manager of the machine or computer. It handles a variety of tasks, but with multiple cores, it can manage even more tasks at once. Each core can work on different tasks simultaneously or split complex tasks to improve overall processing speed and efficiency. Next is RAM. RAM stands for Random Access Memory. This is the main memory used by your computer to store data that the CPU needs quick access to. Unlike VRAM, which is used by the GPU exclusively, RAM is used by the CPU. This brings us to disk space. This is the storage capacity of your computer, where all your files and applications are saved. When needed, the data from the disk is loaded into the RAM for quick access. If RAM is like the memory your brain actively uses to do tasks, disk space is like a filing cabinet where everything is kept for long-term storage. When renting a GPU, it is important to consider how these components work together to meet your needs. For example, if you're doing high-end gaming or 3D rendering, you'll need a good balance of powerful GPU, ample VRAM, and plenty of RAM and CPU power to ensure everything runs smoothly. Similar to this instance here. We can start this instance by clicking the Start Instance button. Now this may take a few seconds to a few minutes, but whenever the setup process is complete, we'll be redirected to the instance detail page. Now that we are at the instance detail page, we may see some information that we have already seen before, as well as some new, such as the instance start time and instance runtime. These values are displayed because ComputeGrid's rental service is time-based. You only pay for the exact time you need, so if a guest rents a machine for only half an hour, they'll only be charged half the hourly rate. Below that are SSH commands and password. SSH, or Secure Shell, is a network protocol that allows for secure communication between two computers connected over an unsecured network, such as Internet. It works by requiring a password or through SSH keys. SSH keys are a pair of cryptographic keys, one private and one public. The private key is kept secure on the machine and the public key is added to the server. When you attempt to connect, the server asks the machine to prove it has a corresponding private key. The private key is then used to encrypt a message that the server can only decrypt with the public key, thus verifying your access securely. If you recall earlier at the profile page, users are able to set their own SSH public keys to avoid having to put in the randomized password each time. Once authenticated, all data transmitted between the machine and the server is encrypted. This means that even if the data is intercepted, it cannot be read by anyone who doesn't have the encryption key. Once connected via SSH, users can run commands as if they were physically at the machine. This allows for the dynamic control of the GPU instance, such as starting or stopping processes or installing software. Example of what can be done with SSH and GPU instances can be seen under Example Machine Learning Workflows. As you can see, ComputeGrid already comes with some specialized software installed, such as Llama and Llama 3, a language learning model developed by Meta AI that is similar to ChatGPT that opens up and runs in your own personal terminal. The difference between ChatGPT and Llama 3 is that Llama 3 was trained on a massive data set of text and diverse sources, whereas ChatGPT was trained on a subset of the internet. Furthermore, Llama has learned to adapt its responses to individuals' interests, preferences, and communication styles, allowing it to respond in different ways. This allows users to not only ask questions they cannot ask ChatGPT or other language models, but also get responses they would have had difficulty getting elsewhere. ComputeGrid also includes Stable Diffusion and Comfy UI, an AI text-to-image model that lets users make custom images with a high level of control. We can see that there are instructions for SSHing commands, similar to on Llama 3, but if you're not quite comfortable using your terminal, there is a one-click Launch XDXL button. This will run the commands for you. It then works quickly to allow us access to the Comfy UI and the Comfy UI default workflow. Here, if we click Q prompt, we can see the workflow working to produce the default image for us. We can also navigate to our rented instance detail through the My Instance Details tab. On the My Instances, we can see all the instances I have rented along with their status, and our current one has a status of running. Above the My Instances tab is the My Machines tab. This is used for users that would like to host their machines. As you can see, it's fairly simple. Once we click Add Machine, we put in our machine name, and then ComputeGrid will download a setup script that will automatically provide all the necessary details to ComputeGrid. From here, the only tab left to explore is the Transactions tab. Here you can view your account balance, earnings, and all your transactions. You are also able to fund your account using the Add Funds button. Here we can see my current running instance with the status of pending. As mentioned earlier, this is due to ComputeGrid's time-based systems. If I go back through the My Instances tab, go to My Instance Detail, and click Stop Instance, and then go back to my Transactions page, I can see that my instance has completed with the status of completed and my duration time. I have now successfully rented, used, and stopped a GPU instance. That concludes our quick overview of GPU resource sharing and tour of ComputeGrid. If you have any further questions, you can look at our FAQ tab or message support via email or Discord. Thank you for your time and interest in the world of GPU resource sharing.